Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. In the previous video, we looked at limit of a function of one variable, and we said limit as x is approaching a of f of x is equal to L. And we looked at the limit definition, and we said given epsilon greater than 0, there is this delta also greater than 0, such that whenever absolute of x minus a is less than delta holds, then when you find the distance between f of x and L, this is less than epsilon. So that was for first variable or single variable. Now let's look at two variables. We are going to use the same definition here, and we are going to just add something small to that. So if you know how to do this, is good. Like this become easy. So let's see how we are going to differentiate this. I said differentiate. Let's see how we are going to define this. So given epsilon greater than 0, there is this. So almost the same thing here. There is this delta greater than 0, such that whenever. So now remember, we looked at the distance between x and a. Now here x is approaching a and b is approaching, y is approaching b. So here we are going to have absolute x minus a less than delta and absolute y minus b less than delta. So you see that we have introduced another variable except this, right? So we are saying that if this one holds, then absolute of f of x y minus L is less than epsilon. So almost the same definition. The only thing that is changing here is now this is f of x and this is f of x y, and now we have this one here and we have added the y aspect to it. So this is the limit definition for two variables. Now let's take examples to learn how to use this definition. So you see, the more you practice, you always write this definition, and it helps you to remember the definition always. And the more you practice too, it helps you to get yourself with different questions and how to do the manipulations. Some of the questions, when you see them for the first time, and if you have not done enough practice, it's going to be you're going to spend too much time on it before you'll be able to, get the right procedure. Okay, so let's see here. Now I want to use epsilon delta definition to prove this. So now we start by writing the definition. So given epsilon greater than 0, there exists delta also greater than 0, such that absolute x minus 1. So you can see that the distance, this is x, so coordinate should be less than delta, and then absolute of y minus 2 should be also less than delta. The same thing here. And if you follow along from the previous video, this one should be very easy for you. Host, then absolute of 3x plus 2y minus 7 less than epsilon. So when you look at this here our f of x from the definition that we wrote is equal to 3x plus 2y. Our L is equal to 7. Our a is 2. Our a is 1, and our b is equal to 2. So we are just rewriting this by replacing a, b, f of x, y, and L inside the definition to have what we have here. Great. Now that we have this, now we want to prove that yes, indeed, this is less than epsilon. Then we can say that, okay, now this is true. But always, for you to go, first do direct substitution and see if it is equal to 7. Then it means that when you prove it, it should be true. But if it's not equal to 7, then it means that it's not going to work out. So let's check this one out. Plug in 1 here, and we are going to have 3 plus 4. This is equal to 7. Indeed, this is correct. So now let's go through the procedure. So I'll start by saying absolute of 3x plus, okay, this one should be 2y. Thank you. So 2y minus 7, and this is equal to, so the idea with using epsilon delta definition is anytime you are doing the manipulation, we are trying to manipulate this in a way that we have one of this here so that we can replace it by delta. So looking at this, we need x minus 1 and y minus 2. So now if I write absolute of 3x, I need something like x minus 1, but here x is multiplied by 3. So I need to make sure that I have minus 3 here, so that when I factor 3 out, now I have x minus 1, which will be the same as this, right? But it's not always the case that you just write it this way. That's why I'm saying that every question and how you are going to approach it. So this one, since we have 7 here, I can take minus 3 from 7, and it is going to be left with minus 4. So this is minus 3 minus 4 is equal to minus 7. So I just pick one of the here. Then I have plus y, 2y, and here too I need y minus 2. So I need minus 4, so that when I factor 2 out, it will be left with 2 here, and I have the minus 4 here. So this is kind of like straightforward, and we have this one here. So now what can we do here? Now let's try and write this one like this. This is the same as 3x minus 1 plus 2y minus 2 absolute. Then we can use a triangle inequality to, split this into 2. So this is less than or equal to absolute of 3x minus 1 absolute plus absolute of 2y minus 2 absolute. Now this is constant, right? 3. And when I pick absolute of it, I can just bring it in front. And this is equal to, so make sure you look at the inequality here. If I write equal to, it means that what is here is the same as what I'm coming to write here. But this means that what is here is greater than what is here. So that is basically the idea here. So this is going to be 3x minus 1 plus 2y minus 2. So now we're able to establish x minus 1, which is here, and then y minus 2, which is also here. So we can say that they are all less than delta. So this is going to be less than 3 delta plus 2 delta. And this is the same as 5 delta, right? So now here we can choose, right? So we choose delta to be equal to epsilon. So always we choose, anytime we are done with this and it's depending on delta and we are choosing, we choose delta to be equal to epsilon. But we need to divide epsilon by the coefficient of the delta that we have here. So if there was no 5 here and this 1, when you divide this one by 1, then it's the same as delta, right? But this is 5, so we need to divide this one by 5, right? So that now we can have, since this one is the same as this, now we can have this one to be the same as equal to, because we are using equal to sign here. So I can do direct substitution here and have 5 delta over 5, epsilon over 5, and this is the same as epsilon. So now we can see that absolute of 3x plus 2y minus 7 is less than epsilon. How did I see that it's less than epsilon? This is the last sign that we use, that we are saying that everything here is greater than this. So this is less than epsilon. As soon as you prove that it's less than epsilon, then you have gotten the right answer. So here we can say that for any epsilon, less than this, so we can write the same definition here to do the conclusion, right? And so for arbitrarily epsilon greater than 0, whenever oh, let me write well, whenever absolute of x minus 1 is less than delta and absolute of y minus 2 is less than delta wholes, then this is true. Limit as x and y is approaching 1 and 2 of the function, which is 3x plus 2y minus 7 is equal to 7. Yeah. So we are saying that if this is greater than 0, and remember this one is arbitrarily close to 0, and this is this, and this is this holds, then indeed this limit is equal to 7. So this is the first one to prove. Let's see if we can have another one which is going to be different way of solving this. So let's look at this one again. So this one too, we are going to do the same thing. So I don't want to be writing more so that the video is going to be long. So I'm just going to copy the same definition here again, or let me just write them so that we can also follow along whilst I'm writing. And so given epsilon greater than 0, there exists delta greater than 0 such that whenever absolute of x minus 1 is less than delta and absolute of y minus 1 less than delta holds, then what can we say? We can say that absolute of x squared plus y squared minus 2 is less than epsilon. So we need to subtract. It's just like you are bringing this one here. So if it is minus, then this one becomes positive, because when you move it here, it becomes positive. So now that we are done with definition, now we try to manipulate this. So absolute of x squared plus y squared minus 2 is equal to, so as I said, we are trying to get this one here, this one here. So we need something like minus 1. So we can split minus 2 to minus 1, minus 1. So minus 1 minus 1 is equal to minus 2. So we can write this one as absolute of x squared minus 1 plus y squared minus 1. So minus 1 minus 1 is minus 2. Now what we can do here, now this is the same as absolute of, so here we can use difference of two squares here, because 1 is also the same as 1 squared. So I can write this one as x minus 1 x plus 1 plus same for the y minus 1 y plus 1. Nice. Now that we have this, we can use triangle inequality here. So don't forget that. This is the same as absolute of x minus 1 plus 1 plus absolute of y minus 1 x y plus 1. Great. Now this is the same as absolute of x minus 1 absolute of x plus 1 plus absolute of y minus 1 absolute of y plus 1. Now the good thing is we have x minus 1 y minus 1, which is here. Now the bad news is we have x plus 1 y plus 1 here. So if you watch the previous video, we have so many ways of making sure that we get this one done, right? So what are we going to do? Now we can, have two ways of doing this, right? So another one way you can do this is, now we said you can write this one as this. So we can say that this is the same as absolute of x minus 1 absolute. Now I want to write this one in a way that I'll get x minus 1. So I can write this one as absolute x minus 1. So I write this one x minus 1, but I need to add something to this such that when I add them, I'll get x plus 1. So what should I do is I need to add plus 2 so that minus 1 plus 1 is going to be 1. And when I add it back, I have this one. So I do the same for y. Absolute of y minus 1, absolute of y minus 1, because that one too, we need minus 1 plus 2. And then the manipulation goes on again. So what we can do here is we can also use the triangle inequality. So I think the best way to do this is to do it and come and place it inside. But still we can use the triangle inequality here to do that. So this is the same as less than or equal to absolute of x minus 1. Then this one can be written as, in parentheses, absolute of x minus 1 plus absolute of 2, which is the same as 2, right? Good. So we want to split this one into 2, this one here. So what I want to do is I have x minus 1 plus 2, and this is less than or equal to absolute of x minus 1 plus absolute of 2, which is the same as 2. So that's basically what is happening here. And it's multiplying this, so I need to put it in parentheses. Great. Now plus absolute of y minus 1. Now this one to the same thing, absolute of y minus 1 plus 2. Great. So this is what we have. This is what we have. Now you see that we can replace this one by delta, this one too by delta, the same thing for this because we have it here and there. So now we can use less than, this will be delta in parentheses, delta plus 2 plus delta, delta plus 2. Great. And this is the same as, because we are going to expand, and we have delta squared plus 2 delta plus delta squared plus 2 delta. And this is also the same as 2 delta squared plus 4 delta. So we have something like this. Now, the good thing is, okay, we have 4 delta here, but the bad thing here is we don't have delta here. This is delta squared, so we cannot add. That's the only bad news here. So how can we do this? Now we need to choose delta in a way that we can add these two components. Okay, so what we are going to do it, we are saying that delta is greater than 0. So we want to choose something close to 0, right? So I'm going to choose delta to be less than or equal to 1. If delta is less than or equal to 1, then I can choose the maximum of delta, like 1, and plug in 1 here. So when I plug in 1 here, 1 squared will be 1. 1 times 2 is 2. So here is 2. 1 times 4 is going to be 4. Then I can add this. So what I'm doing is, when I plug in 1, I'm going to have 2 times 1 squared plus 4 times 1. This is going to be 2 plus 4. And this is going to give us 6. So when I choose delta to be less than or equal to 1, this is what is going to happen. So I'm going to have this one to be less than or equal to, because we are choosing this. And this is going to be 2 delta plus 4 delta. So that's basically what is going to happen here. Great. Then now, this is the same as 6 delta. Now somebody is asking, why are we choosing delta squared to be delta? Because we are picking 1, and delta squared, which is the same as 1 squared, is the same as just delta. So kind of like this is the same as this, right? And we are using less than or equal to because when we choose something like 1 over 2, this will be greater than this. Because if I choose something like 1 over 2 for delta, what is going to happen here is I'm going to have 2 times 1 over 2 squared is going to be 1 over 4, right? So 1 over 4 here is 1 over 2 plus this, we choose delta to be 1 over 2. So this will be 4 times half, which is going to be 2. But here, when I choose delta to be half, this one here is going to be, half will be 1 plus half here will be 2. So this is going to be 3. And this is not up to 3, right? So here, delta is between 0 and 1, right? So that's basically what is happening. So anything that is less than 1 and also less than 0, anything that you are going to choose here, this will always be greater than or equal to this. Now it will be equal to this when delta is 1, but anything less than 1, this will be greater than this. That's why we are using this one too here. So we have this one, and as I said, as soon as we get something like this, we need to choose delta again to be equal to epsilon. So choose delta to be equal to epsilon, but we need to divide it by the coefficient of delta, which is 6, so that now we can have this one to be 6 epsilon over 6. We are just doing substitution here, and this is going to give us nice and beautiful epsilon, right? So that's basically what is happening here. So if I just decide to um, shift things small to this side, then I can conclude that absolute of x squared plus y squared minus 2 is less than epsilon. So that's basically what we have concluded, because this is equal to delta, and starting from here, we have it to be thus. So that's basically what is going to happen here. Nice. And we can just do our conclusion from there. So should be able to write a conclusion. We have done a couple of them, so you can do that. Now let's look at this beautiful question. So you look at the first one that we did and the second one. So every question and then the strategy. So you should be able to practice more to see how you'll be able to tackle epsilon delta definition question. Let's go through the same process again. Definition. I love writing the definition, right? The more you write, the more it sticks. So every question that you write, don't be lazy to write the definition again. So this such that whenever absolute of x minus 1 is less than delta and absolute of y minus 2 is less than delta. So don't forget, this is basically coming from here. So x minus x 1 and then y minus 2 is coming from this here. Holds, then absolute of, so we pick this one and we subtract this one from it. So x plus 2 over y minus 2 is less than epsilon. Nice definition here. So now let's look at how we can do the manipulation here. And everything that we are doing here is analysis, right? You are trying to, do the thing very well. But now, first, let's check if this is true. Plug in 1 here and plug in 2 here. It's going to be 1 plus 2 over 2. 2 over 2 is 1. So 1 plus 1 is equal to 2. Indeed, that is right. So now we can go through the process and see if this is true. So let's see. Absolute of x plus 2 over y. 2 over y minus 2. This is the same as, so we need to come here. That's what we need. So we need to check if, okay, this and this. So we need x minus 1. So now we can split the minus 2 to minus 1 and give minus 1 to this guy. So we can write this one as absolute of x minus 1 plus 2 over y minus 1. Great. Now what can we do? We can use triangle inequality to split this. Less than or equal to absolute of x minus 1 plus absolute of 2 over y minus 1. So we have this one here. Now the only issue here is this, and every issue has a solution. So let's try and resolve this issue here. So now this is the same as absolute of x minus 1. So I told you how I'm using this one. So if I'm using equal to sign, it means that it's equal to what is here. Plus, now here I can have this one to be divided by 1. So I want to simplify this, and I'm going to have 2 minus y divided by y. 2 minus y divided by y. So what is happening here is I have 2 over y minus 1. This is basically divided by 1, right? So I multiply this by this, which is 2, and I multiply this one by this, which is y, divided by this times that, which is this. Great. Now, one thing that we need to also know from here is we know that absolute of a over b is the same as absolute of a divided by absolute of b. Nice. If that's true, then we can write this one as absolute of x minus y, x minus 1 plus absolute of 2 minus y divided by absolute of y. Now, here the case is we don't want this one to be 0. And indeed, y is approaching 2. So it can never be 0. But let's do some small analysis here and see what is coming to happen, right? Now, if I have absolute of 2 minus y, we know that this is the same as absolute 2 minus y, right? This is true. But let's see something. If I decide to divide the left side by absolute of y, then what happens? It's like you having a number and you want to divide it by something. That number is going to reduce. For example, if I have 4, which is the same as 4, then if I divide 4 by 2, is it the same as 4? No, this is not the same as 4, right? So now this here is going to be 2, and this one is going to stay the same 4. So it means that this is going to be greater than 2, right? So that's basically what is going to happen here. So now since y is something approaching 2, we are assuming that y, when we divide this one by y, this is going to be less than this. So we can say that, okay, this now changes from equal to sign to, let's say, less than or equal to. Even y cannot be 1, right? Yes. So it should be strictly greater than that. So that's basically what is going to happen here. So if that's the case, then we can say that, okay, this is less than, we use this one here because of this sign here. And we are going to have absolute of x minus y plus, then we are going to replace this by this because this is greater than this. And then we have something like absolute of 2 minus y. This is beautiful, right? This is very, very beautiful. Now, what can we do here again? Okay, can do some small manipulation here. We need y minus 2, not 2 minus y. So what we can do here is very simple. Now, when you are very good with this one, some of the steps you can just skip them, right? I'm just trying to explain for you to understand each step why we are getting here. So x minus 1 plus, now 2 minus y is the same as minus y minus 2. So that's basically, this is true. And when I take the absolute of 2 minus y and then absolute of minus 2 minus y, this is the same as absolute of minus 1, absolute of y minus 2. Absolute of minus is positive, so this is the same as this. So this is the same as swapping the 2 and y. So this is the same as y minus 2. This is beautiful. Okay. Now that we have everything here, this is here, this is here. Now what we can do is, now we can replace this one by delta plus delta. And this is the same as 2 delta. Let's choose delta to be equal to epsilon, but divided by the coefficient of delta. So this is going to be 2 epsilon over 2, which is equal to this. So now we can conclude that absolute of x plus 2 over y minus 2, I think so, yeah, is less than epsilon, which is beautiful, right? So manipulations everywhere and each question what you need to do. We have so many questions and so many strategies that we need to use to get to the right results. I think this is the last question, then I'll give you a trial question to also do it. I appreciate you to leave your answer in the comment section, and this being proved, you can take a picture of your solution and you post it in the Merbs Connect community. Sure. So now let's see what we can do here. So now the same idea again. Oh, somebody is getting annoying. I love writing this definition. Yes, of course. Yeah. So let's write it again. So epsilon is greater than 0. Such that. So here, another one that you can see is, we can make sure that delta depends on epsilon. It's also correct because you see, delta should be depending on epsilon. That's the reason why always we choose delta to be equal to epsilon, yeah. So we can also use putting something small here like epsilon, right? Delta depends on epsilon. So it's also the same thing, such that whenever absolute of x. So now remember, we are going to do x minus what is here, but this is already minus. So it's going to be like x minus minus 3 absolute. And this is the same as x plus 3. So pay attention there, because we need to do x minus what is there, but it's minus already. So this is what we are going to get. And absolute of y minus 3 is less than delta holds. Then we are going to have absolute of, let me just bring this one down here, absolute of 4x squared minus y squared minus 27 less than epsilon. Now let's do direct substitution and see what is going to happen here. Plug in 3 squared is 9. 9 times 4 is going to be 38, I think so. And then 3 squared is 9 minus 9. So this is indeed, is it 29 or 27? Am I getting this one right? 9 squared is, 3 squared is 9. 9 times this should be, okay, let me see. Let me just break it down. So 4 times 9 should be 36 here. So this one should be 36. Okay, so 36 minus 9 is now 27. Great. So this is true. Now let's now go through the process again and again. So now let's pick x squared minus y squared minus 27. Now let's check what we are looking for. So we're looking for x plus 3. Now, don't forget this x squared here. So here is going to be nice. Very, very, very nice and very, very challenging, because, you know, we have something like 4 in front of this guy here, and we have y here, but this y here, we need it to be minus this. So since this is going to be minus, we need to add and subtract. So what is going to happen here is, now we are checking out something to see what's going to happen. Now 4 times what is going to give us 9. Remember, we saw that 4 times 9 is going to give us 36. So here 4x squared, we need to subtract, we need to add, we need to add because we are adding here. Where is it? Oh, we need to subtract. Let's subtract. Subtraction will be best. We need to subtract or add. Okay, let me add and see. Add 36 to this. So that when I factor 4 out, x squared plus 9, and because this is positive, it's going to be very difficult for us to do the difference of 2 squares. So what should you do? Okay, I'm coming. Let's check it out. Yeah, so we need to subtract, right? Because we need to do difference of 2 square here. So minus this and minus that. Great. So when you do this, this is going to be nice, nice, nice. So now when I do something like this, so we are doing analysis here. So when I factor this one, so now that I can write this one as 4 and I can write this one as x minus 3, x plus 3, because 9 is the same as 3 squared. So we can use the difference of 2 squared there. Nice. So now we have minus y squared. But remember that this should be minus what? 27. And we've already taken minus 36. So what should we add to this minus 36 here to get this? So we need to add plus 9, right? So this is what is here. We want to make sure what is here is the same as what is here. So we have 4x squared, we have 4x squared. We have minus y squared, we have minus y squared. So we need to make sure that what is left here, when we add, we get what is here. So minus 36 plus this is going to give us minus 27. Great. So that now we can write also this that we have here as, I can factor minus out so that I have y squared minus 9 in parentheses, right? So when I subtract, when I factor this minus out, this is what's going to happen. So multiply this one by this, have minus y squared, and minus minus will make it positive. So that this one too will be minus y minus 3, y plus 3. So this is crazy, right? Like, you should be able to know how to manipulate this to get to the right destination. So always you need to practice to, know the strategies to use. So now let me write. Now that we know this, so what's going to happen here is going to be absolute of 4x squared minus 36. So how did I knew that I need to subtract minus 36? This one was squared. So I was thinking of, since this one is 4, I need to put something here in a way that when I factor 4 out from here and factor 4 out from here, what will be left is going to be perfect square. I mean, something that I can raise it to the power 2. So perfect square, let's say 2 squared is 4, like 1, 4, 9, 16 in that order. So that's basically what I was looking for. And I had the 36, so that when I factor 4 out, it will be left with 9. Then minus y squared. Now I want to make sure that this is equal to minus 27, so we need to add the plus 9, which we did there. So follow up from what we did here. This is the same as factor 4 out, x squared minus 9, minus out y squared minus 9, and this is going to give us 4x minus 3, x plus 3 minus y minus 3, y minus plus 3. Great. So we have this one here, so we can erase this. All right. So now we can use triangle inequality and have this one to be less than or equal to absolute of 4x minus 3, x plus 3, plus, even though this is a minus, when I use it, I can change it to plus, right? Plus, the reason I'm changing it to plus is I can write this one as plus absolute of minus y minus 3, y plus 3, right? So nothing has changed. But because of the absolute, this minus here can just go away. So we are going to have something like this. Absolute of 4x minus 3. Okay, so let me write this one again. So this one I can factor the 4 out and have absolute of x minus 3, absolute of x plus 3, plus absolute of y minus 3, absolute of y plus 3. Great. So this is perfect, right? This is perfect. So now we have y minus 3, which is here, and we have x plus 3, which is here. So the only issue here is the x minus 3 and the y plus 3. So I'm not going to use the first approach that we use for the second question. I want to use different approach here to do this one too. So now that we want to get this here, so let me write this one here. We have absolute of x plus 3 less than delta. So we want to make sure that we have this one to be this, like kind of like this. So here we are going to choose delta to be less than 1, such that we can have this one to be x plus 3 less than 1, right? So I'm choosing for delta here. And then now this is the same as minus 1 less than x plus 3 less than 1. So we can write this absolute like this. Then what can we do here? Okay, we want to have this one here to be x minus 3, right? We need this one here. So what should I do? We don't want x plus 3, we want x minus 3. So what should I add to 3 so that I get minus 3? That's minus 6, right? So minus 6 means that add minus 6, add minus 6, add minus 6. That's what's going to happen, right? So let's do that. minus 6 minus 1 less than x plus 3 minus 6 less than 1 plus. This is going to be minus 6. But this is going to be crazy. Let's see what's going to happen here. Let's see. This is going to be minus 7 less than x minus 3 less than minus 5. So what is going to happen here is that this is minus and this is minus. Issue arise. So it means that what we can do here is to, okay, let me pause here and use the other approach to see if it's going to confirm with this one, because mostly when I do it, this one's supposed to be positive, right? So let's check the different approach here. So I'm just going to quick, I will explain. So this is the same as 4 absolute of x plus 3 minus 6, which is true, absolute of x plus 3. So what I want to do is I want to add this one in the same way that I have this one again. So this is true. And this is the same as, this is less than or equal to 4 x plus 3 minus, okay, so this is going to be plus 6 when I use the absolute sign. So it's going to be making this one more complicated. So let's choose this one up, this approach, right? Because of the minus here, right? Let's choose this one approach, because when we pick the absolute, this one should be positive and we don't know the one to choose, right? So let's use this approach here. Okay, great. So we want x plus 3 here. So we do x plus 3, but we want to add something to 3 such that we get minus 3. So that is minus 6. We do the same thing for this one. Now this one, we want the y minus 3, but we want to change the y plus 3 to y minus 3. So this is going to be y minus 3 plus 6. Why? Because now when I add minus 3 to 6, I get this one here. So let's use triangle inequality to have this one to be 4 in parentheses, x plus 3 plus 6, right? So when I use triangle inequality, when I take the absolute of minus 6, I get a 6 here. And then absolute of x plus 3 plus absolute of y minus 3 in parentheses, y minus 3 absolute plus 6. Great. So now what is going to happen here is very simple. Now we have everything. We have the x plus y and we have the y minus 3. So we can now chip in the delta and have 4 delta plus 6 delta plus delta plus 6. So this is what is going to happen, right? Then now this is the same as 4 delta squared. So 4 times delta will be 4 delta squared. And then 4 times 6 times delta is going to be plus 24 delta plus delta squared plus 6 delta. Great. Now we can choose delta to be less than or equal to 1. And this is going to be less than or equal to 4 delta plus, okay, let me simplify this before I choose. Okay, so this is the same as 5 delta squared plus 30 delta. So now we can choose delta to be less than 1, and this is less than or equal to, so I already explained this. So this is going to be 5 delta plus 30 delta, and this is equal to 35 delta. So we choose delta to be equal to epsilon divided by the coefficient of delta here, which is 35. So this is going to give us 35 epsilon over delta, epsilon over 35, and this is going to give us epsilon, right? So some of the approach, so that's why sometimes you need to know the 2 approach or the 3 approaches, because Sometimes some of the questions you need to use this, some of the questions you need to use this. So assuming that I learned the one that I just wanted to use, I'll be stuck there and I won't know what to do. So it's good for you to know all the two approaches. It's very good. Yeah. So this is the last example that we want to go through. So this is a trial solution question for you. This one, I would like you to solve it and combine all of them as if you solve A, B, C, don't post them one by one in the community if we are doing that. Just take a picture of all the three and you can do multiple selections so that all the solutions come as one and then we can check it for you if we are doing it right. There is no whether you are getting it wrong or right. We are all learning, right? We are in community of learning. So we are all trying to learn and improve. All right, so I'll leave you here and don't forget to subscribe, to like and comment to help us grow to reach more audience, and see you in the next video.